Unit 4 log functions.
The exponential growth formula t equals a1 times r plus 1 to the x power a1 equals initial value r equals rate of increase r is greater than 0 x equals time p equals n value.
Alright, so now decay. P equals a times 1 minus r to the power of x. A is the initial value, r is the ratio of the decay, and r has to be greater than 0 but less than 1. And x is the amount of time given in the problem. P is the end value after decay. And half-life is P equals a times half to the power of x over h. A is the initial value, x is the amount of time indicated in the problem, h is the amount of time in which the half-life of the substance occurs, p is the end value after decay.
Now to interest. There are two types of interest, compound and continuous. Compound interest, the formula is a equals p times 1 plus r over n to the power of n times t. P equals the principal value, which is the initial value. R equals rate, which is percent in decimal form. N equals number of periods that the interest goes through, and T is the time allotted. For continuous, the formula is A equals P times e to the power of RT. P equals the principal value, which again is the initial value. R equals the rate, which is again in decimal form. T is the time allotted, and E is a infinite number that equals 2.718281, etc.
The properties of logs. Product property is log b mn equals log b m plus log b n. Quotient property is log b m over n, which is equal to log b m minus log b n. Power property is log b m p log b m.
Here are some examples on how to solve logs without a calculator. One of these examples is log 5x equals 2. Using the exponential formula for a log, we know that 10 to the power of 2 equals 5x. 10 to the power of 2 is 100. Now divide both sides by 5, and that's how we get 20. And here are some more examples to look at, so pause the video.
Alright, solving exponential equations, logs and natural logs. So the first example is pretty simple. So as we see, there's log 5 to the power of 7 equals 7. Now we know log 5 and 5 is just 1 in general, but the reason being is whatever's down here, 5 to the power of x equals to this value up here. So 5 to the power of 1 obviously is 5, so log 5 would just be 1. And bring down the exponent up here, down here, so it'd be 7 times 1 equals 7, and 7 equals 7 is obviously correct. And then we go down to the example number 2, where it's 4e to the power of 3x minus 1. As we know, e is the opposite of natural log, so you divide by 4 to the other side, and that would be 5 over 4. And you're left with e to the power of 3x minus 1 equals to 5 fourths here. And then what you do is you natural log both sides, and what that does is it brings natural log here and natural log here. So now it's natural log e to the power of 3x minus 1 equals natural log 5 over 4. And as we know, natural log has a base of e, so this would just cancel out, L and e, natural log e would just cancel out, which you're left with 3x minus 1 equals to natural log 5 to the fourth. And then then you'd add 1 to the other side, it'd be 3x equals natural log 5 fourths plus 1, divide everything by 3, and that would be x. You end up with x equals natural log 5 fourths plus 1 over 3, and you can do that in your calculator and you'll get x equals 0.4. I'm not going to explain the last one, so pause the video. Alright, so evaluating logs. As you can see in the first example, if you've already noticed that all of the numbers have the same bases. They have a base of 6. So looking to the other properties, you can make this just 7 times 8. If you looked at the properties, you can go back in the video, look at the properties again. If they have the same bases, you can just multiply both of these. As you can see right here, there's the 56. 7 times 8 equals to 56, obviously. So that's one of the easier problems. And now I'm gonna do one other example right here. Alright, as you can see, this example, 3/2 times log base 2 4 minus 1/2 log base 2 x equals to 3. So what we're going to do first is we're going to take this 3/2 and we're going to move it right here, up here to the exponents as well. And we're going to move this 1/2 up here with the exponents right here. So now we have log 2 4 to the power of 3/2 minus log 2 x to the power of 1/2 equals 3. Okay, so now you can put this in your calculator right here, 4 to the power of 3 over 2, and that'll give you log 2/8 minus log 2x to the power of 1/2 still equals to 3. Now what we're gonna do here is that now these are the same bases as you can see again, look at this, base 2, base 2. So all you're gonna do is, if you look at the properties again, you can back the video, it would just be 8 over x to the power of 1/2 equals 3. Bang. Right? So now what we're going to do is we're going to cross multiply. So we're going to put 1 over here, and then we're just going to cross multiply, and it's 3x half equals to 8. Right? And now we're just going to divide 3, and then we're going to take x half equals 8 over 3, and now we're just going to take this power to the half, and this will become a square root. So now if you plug that into your calculator, you'll get x equals 1.63, and that is your answer.
By the end of this lesson, you should be able to 1. Understand exponential growth, decay, half-life, and compounded/continuous interest. Also, be able to solve problems involving or related to these. 2. Comprehend and apply properties of logs. 3. Solve log equations with or without a calculator. 4. Pass Unit 4 of CCM3.